Welcome to the Cape Computer Science Unit 1 IA walkthrough. This video is part of a series of 7 videos, I think, that will give you a full start to finish walkthrough of what the Computer Science Unit 1 IA is supposed to look like, giving you examples, working on the code, showing you the documentation, and giving you all the little tips and tricks in between about how you should approach your IA. So I hope you learned something, but just remember, I'm not a teacher. Whatever your teacher decides to tell you to do, follow what your teacher says. This is for people who don't have teachers, if your teacher's sick, or you're doing it on your own, right? So, enjoy! Alright, so we're going to go through pseudocode today. So we would have given our narrative, we've said the things that's supposed to happen. Narrative doesn't have to be too super technical. You could add in more technical stuff, but as I said, there are actually no marks in the IA for narrative. So whatever we have in the narrative here, it's just kind of like icing on the cake. However, there are marks for the pseudocode. So let's look at what the pseudocode should look like from a technical perspective, right? So pseudocode is a breakdown of the program from start to finish to include comments and explanations of what is happening. So it should not look like C programming. Be very, very, very careful to make it not look like C programming. While I'm going through it, I'll clearly show you certain things that you should not do, especially if you are reverse engineering it, right? But if you do the pseudocode without writing with the C code, you will avoid that problem. But if you're reverse engineering, you might end up in that problem if you take the C code and turn it into pseudocode. So that's why I'm doing the pseudocode first. So you don't have that problem of trying to make sure that you have to not make it look like C because you're copying and pasting from a C program, right? Sorry to interrupt the video, but this is future me talking to you while you're watching this. And if you are struggling with a certain part of your IA, or you just need some way to check over your IA, we do personal one-on-one IA classes. So if you want your IA to get a check over, just to make sure you have all the requirements on the marks, makeITsimpleTT.com/register. Okay, cool. Back to the video. So let's go. So for structure, when you want to declare a structure, you will just put the word structure name, student. Usually putting the name of stuff on colons gets you where you need to be when it comes to pseudocode. So you shouldn't have a problem there. So I'll put the structure name, the elements of the structure, and then create an array of structures. Basically, you don't need to put data types in pseudocode because the data types actually come into the code. For an array, you could just put array colon, the name of the array, and then create the array. For a file, all you have to do is open file in input mode. And for a function, you list out what the function is going to do by putting the function name, what the inputs are, and then start and end will tell you how the function starts and ends. Same thing for another function. So we want to now start to jump into the pseudocode for this particular problem. Now, because it's going to be eventually written in C, you will probably want to lay it out in a way where C will be able to understand it. Now that may include something called function prototyping. I don't know if the pseudocode, if you write out your C program and you use function prototypes, then you should list them out here. If you don't know what function prototypes are, then don't worry. Your program will still work. So I'm going to lay out the code in a way where it'll make sense to me, right? So before I lay it out, I'm going to put comments to say, okay, this is structure declaration here. Because you might have global variables like a counter or some kind, or the max size or something like that. Then after global variables, I will put file declarations. Now when you put the file, when you declare the file outside, that means anybody could, actually no, I won't do the file declarations here. Should I do the file declarations here? No, I won't do the file declarations here. File declaration should be done inside functions. So that I open the file and close the file and then move on with your life. Because if you leave the files global, weird stuff can happen. Yeah, right, good. So then the next function I should have, according to my function requirements, I should have a password. Password function. After putting the password function, I should put the read file data function. after I read the file data, I probably want to put in the I'll put in the add patient function. Then I'll put in the update patient. Then I'll do search patient. After I do the search patient, then I want to do remove patient. Then I want to print to screen. Print patient info to screen. And then I want to print critical patients. Now, so these are the things that I want to do, and in order to do that, I have to be able to think through a what, and then now after display the menu, I'll probably want to add a function before I add that function in. I'll probably want to put in a welcome screen. Oh wait, all of this was going in as heading 1. Wow, that's why it's so big. Myself, why the text looking so big, but normal text. Yeah, right. So declare the structure, deal with the global variables, put in the password, read the file. Trying to put this in as logical steps as possible. Add patient, update patient, patient, remove patient, print patient info to screen. Alright. Now, what you realize, depending on the type of IA that you're doing, some of your functions will not be database oriented functions. This IA sample that I'm doing here is a database driven sample that actually trying to organize and solve a data problem. But you may have a store where you have to do calculation of VAT, calculation of this, calculation of that, searching for items within a database, getting them across using 2 different files. All sorts of things you can do. So I just needed to understand that you're not following this to be like every single IA must be a database driven IA. There are some IAs that could be e-commerce based, where you have a store, you have the information, you have the cost of a certain item, you put in the quantity, you multiply it, you read the information of the price from one file and then you print it out. Some kind of thing like that. Those are very simple IAs to do also. There are some IAs that might be like community service, and you're collecting donations, and when you collect donations, you see who's the donor that put it, you update their structure, and then you could print out how many people donated and all that kind of stuff. All those are things that you could do, and your function should reflect that. You could make your functions do whatever you want. Once you understand functional programming, you just figure out, okay, what do I want to do? What data do I need to do it? What do I need to do to the data? What do I need to send back out? And you're good at that, right? Sorry to interrupt the video, but this is future me talking to you while you're watching this. And if you are struggling with a certain part of your IA, or you just need somewhere to check over your IA, we do personal one-on-one IA classes. So if you want your IA to get a check over, just to make sure you have all the requirements on the marks, makeITsimpleTT.com/register. Okay, cool. Back to the video. And then after I print critical patients, I do the menu function, and then I will do the main. Alright. So these are this basically going to be the things that are available in the program. But I don't know if I'll add more, if I'll remove more, because sometimes when you reach the C programming and you realize certain things difficult, you might just come back to the Pseudocode and be like, forget that function and not doing it again. Which is totally understandable and it's totally acceptable. You'll probably have to consult with your teacher to decide if you could take out a particular function, or if your teacher decides it's a make or break function. Just remember that I told you that most of the times they look for adding, updating, changing, searching, and removing. Adding, updating, searching, removing. Those are 4 things that they always look. So once you could add, update, search, and remove, those are usually what you're looking for in your IA. However you do it. But as I said, consult with the teacher. If you're using this and I'm your only teacher, then use that as your gauge. Once you're doing those 4 things, your function should be robust enough to be able to get most of your marks. All you have to do is add menu and some other function that makes sense, right? So, I always recommend that you go for your main first. Why we should go for the main first is because the main is going to lay out the logical flow of how your program is going to work. And then once you know the logical flow of how your program is going to work, you go and you implement function by function based on the logical flow. That way you can test as you go along. The whole point is, you don't want to just start to throw code on the page and be like, all right, let me just code out this function, code out that function, code out that function. You could code it function by function and then do the main after, but it'll be a lot easier if you do the main, get the main to work, test it, and then test each function piece by piece to see if it is working. That way you'll have a easier run, right? So we're going straight for the main one time, right after I sneeze. There's more. AC too cold. But when the AC not cold enough, I start to sweat. I feel so hard. I'm ready. Okay. So what we're doing is we're going for the main first. Why we're going for the main first is because I think it's the best way to do it, because this goes through all your logic. Let me just double check and make sure this phone's still recording. All right, it still is. Okay, let's go. So with the main, I'm going to go to the function name, function, main, inputs, none. Yeah, so there are no inputs into this, so I'm just going to start with the main, start. First thing I want to do is call the password function. No, call the I want to call the welcome function. After I call the welcome function, I will call the password function. Alright, so the first thing they'll get is a welcome screen, and then they'll get a password prompt. And then I need to catch the password in a variable. So before that, I will have to create a I'll put the variables here. Alright, so variables, I need P. I'll set P to 0. And I'll say P is equal to password. Okay, so once I get this password, I don't want the capitalizations. Don't do that to me. Stop the auto capitalizations, please. You'll get me mad. Right, P is equal to password. Now, from here, if the password is correct, I get to go into the program. So I'll say if password, if P is equal to 1, then no, if P is equal to 0, print. If P is still equal to 0, because if it return back a 1, that means say print wrong password entered. Wrong password entered. Please try again. I could put a counter and make them enter the password wrong 5 times and then exit the program, but I'll do that in Unit 2 when I'm trying to software engineer it to make it more useful, right? So if p is equal to print wrong password entered. So I'll say while p is equal to 0, sorry. While p is equal to 0, print wrong password entered. Try again. And while. So this will put it in a password loop, and you won't be able to get in until you put in the correct password, right? Yeah. So that will give us a simple password loop. Now, it's not perfect. As I said, we're going to take this same program and we're going to make it a lot better in Unit 2. So if you know how to do certain things like these, some of the things that you try to do in Unit 1 and you don't get to do, and you're not able to do it properly, that's okay. You'll get a crack at it in Unit 2. So while password is equal to 0, print wrong password entered, please try again. I will want to put like a timer after that, and if the count goes up to 5, then we'll say exiting program and I'll never call any other menus or something like that. Right? We could put that inside by putting like a if or something. Now, once you get past the password part now, then if it reaches past the password and it says please try again, you could put in you would call the menu function. So we'll put option is equal to 0, and then we'll put option is equal to menu. Because we're going to call the menu function. The menu function is going to display a list of things, and based on the number that they choose, it's going to send it back to the option menu, right? Option is equal to menu. And now we're going to put in a set of if statements. I think they will allow you to put a switch in C, or you could just put in if statements, right? So we're going to say now if option is equal to 1, what do we do? Yeah. Now because it's pseudocode, we could put curly brackets to mention to show what is going to happen. But I just so afraid of using curly brackets because they will say that it's looking like C. I've started to use start and stop, right? Start and stop. What do you do if somebody puts in option 1? And then you do the same thing now for if option. Just now I have to turn on this turn off this auto capitalization thing. I can't remember how to do it, but edit gamma vex, edit, view, tools, preferences, automatically capitalize words. No, take that off. Right, good. All right, good. So now we want to say if opt is equal to 2, what do we do? We have certain things that we have to do, so I'll put an X, start and stop. The reason I'm doing this is because it makes life a whole lot easier. I'm going to change the view to pageless so that it don't... yeah, so that everything will just kind of flow one line after the other, right? Because we're doing pseudocode. So if option is equal to 2, start and stop, what do we do? And we're going to repeat this for how much options do we have based on the pseudocode? 1, 2, 3, 4, 5, 6, 7. All right, 7 options. So we're doing this 7 times. Let's go. All right, so 1, 2, 3, 4, 5, option is equal to 7, start, and stop. Right. So this is going to give us a nice little menu rundown to be like, all right, based on what the option in the menu returns, we know what we have to do based on option 1, 2, 3, 4, 5, 6, 7, all the way down here, right? So option 1, according to my menu choices, is going to be, hold on, before I call the menu, my bad, I made a mistake, right? So before I call the menu, I have to read files, read data. So I'll call the read data function. That will read all the information from the text file into the array of structures, right? But we didn't set up all the array of structures and everything yet. Right now, we're just trying to make a logical flow. As I said, you could do all the structures and all that stuff. All these functions, you could fill them out however you feel like filling them out. That's cool for you. But I just want to go through the logical flow of, okay, what am I going to see? I'm going to see the welcome. Next thing is it's going to ask for a password. If the password returns the value of any value other than 0, we'll go ahead. But if the password comes back as 0 because we set it to 0 at the start, then it will just say wrong and password entered, and it will stay in that loop with that while loop as long as possible. If it, however, passes that while loop, it will go to read data. Read data will read. After you read the data, you will get the option from the menu. So when the menu is displayed, it will tell them what the numbers that they could choose, and once they get back a particular number, then you know which one you're going to do. So if option is equal to 1, I'm going to put the call add record function. If option is equal to 2, what do I do? Update. So add, update, search, right? So call add function. And then I'll do the call update function. Option 3 would be call search function. Option 4 would be remove function and print to screen function. Option 4 will be call remove function, call print to screen function, call critical patients, call print critical function, and then, oh, well, this wouldn't be option 7, as if they get back at 0. This will be print thank you for using the program. No. Call update file function, and then call exit program message. Right. Okay, so our logical step would be so opt equal the menu, and okay, before we do this, we have to encapsulate all of this in a while loop, because the while loop allows to check for 0 each time. So let me tab this. All right, so tab them all, and then I'm going to put here while option is not equal to 0. Pay very, very, very close attention to this. You see this not equal to part here? Do not put an exclamation mark and an equal sign, because that is C programming. You don't want to make it look like C programming, so you're going to say while less than greater than. That's not equal to, while option is not equal to 0. What do? Start. So I'm using start and stop for everything because that just makes it so pseudocodey that they will have no choice but to accept that this child knows pseudocode. If you put start and if you put curly brackets, it's up to them to decide if they're going to accept the curly brackets or not, but they've explicitly stated that it must not look like C code, even though curly brackets make life a whole lot easier. But, you know, start on top is different. Right, so you want to say while option is not equal to 0, and then when you finish all of these options, you want to keep calling back the menu, opt equal menu, right? Now, you put in the option equal menu before the end of the loop because, of course, you want to get back on the option value to check to see what you're going to do each time. So every time they call it back, it should. Now, you could put back call the option and then print back you could print back the menu and clear the screen and all that stuff, but we will deal with that when we get to the C programming part. You could put in clear screens and all that, but those not absolutely necessary if you don't want to do it. So we have our main, and our main is laid out. So let's just run through the main very clearly again. So we name it main, there are no inputs that are coming into the main. The variables that we have are P and option. P is for password and option is for whatever option you choose. We set P to 0. We call the welcome screen. Once we call that welcome screen, it will say, hi, welcome to the hospital, yada yada, please enter your password. While the password is, if the password is 0, still, that means they put in the wrong password, that means the value that was put in for password was wrong. Oh, right, we made a mistake here because we have to, inside the while loop, we have to prompt back for the password again. I didn't put that in. So you'll print and wrong password entered, prompt back for the password. So you call back the password function, read P, and then this loop can stay on infinitely until P returns a 1 or anything other than a 0. So we'll most likely program it to return a 1, right? And then we go through that loop. That loop will keep going on and on and on and on. Once they put in the correct password and it matches, then we read the data. We read the data from the user and we say menu is equal to option. Put in the option. And once the option is not equal to 0, that is what this while loop is for. We go into this list of ifs here. These if statements here will check to see if they're put in 1 to 6. They choose option 1 to 6, so we'll call whichever function we need to do. Of course, we haven't coded the functions, we haven't put in the logic for the function as yet because we just want to make sure our logical flow makes sense. Our logical flow is making sense. And once we reach to option 0, if they put option 0, we'll put update the file and then exit the program. No, why the menu? The menu not supposed to come back up after that. We might have to put in a break or no. We just won't check first to see if the option is 0. Because once the option is 0, it'll stop. So I'll take out this option being equal to 0. Because once the option is 0, the while loop will stop. So once we reach to the end of that while loop, then we will do this part here, which is call the update function. We gotta pass start and stop it because once the while loop stops, we only have two things that we want to do. Update the file function and call the exit program function. Yeah. And then that will be the stop there. This is the stop for the major one. Okay, this stop goes here. Alright, make sure things line up. Right, good. So this stop here is for the stop of the while loop. Once the while loop stops, we'll call the update file function and then we'll call the exit program message. And then we actually stop the whole program. So this is the final stop here. Okay. Alright, so see why it's good to go over the pseudocode and just kind of make sure that logically it's making sense in your head. Now, I know for a fact that some students you go down and go through pseudocode and be like, I don't understand what's happening, because you would rather code it. It's a lot easier for some students to just go and start a code and the logic starts to flow while you're coding it. That's okay. But for the students that are able to understand everything that's happening and they rather have a logical plan before they go and start the code, this is the way that I prefer to teach students, because this helps you understand your algorithmic thinking before you actually just go into trial and error mode with the code. But when we get to the code, I'll show you how you can take your code and turn it into pseudocode after. If you want to do the reverse engineering, that's quite alright. Like, programmers do it all the time. Actually, in the real world, programmers don't really do too much pseudocode. What they just do is, once they know how to code, they just come up with a basic diagram. And once they know the diagram, then they start to code based on the blocks in the diagram. But for us, because we don't know how to code very, very well yet, and not very proficient with the language, planning what you do helps a whole lot. It helps a lot, right? So now I have this layout of the pseudocode. Let me go and start to code a few functions, right? I don't think I'm going to encode every single function in this tutorial, this walkthrough. If I go through every function, tell yourself that like you're blessed or something, because that's a lot of work. That's work for you to do. I rather correct students' work, but I mean, I may just do it, right? So we have this layout. So now let's go and deal with our file structure, right? Now there are two things that need to happen when you deal with the file structure. You have to understand what the patient record is going to be first, and then you're going to have to understand how you're going to read that data in. So the first thing you have to do is you have to create a text file, because there is a full set of marks for where is it? Yes, selection and justification of file structure. So we have to first, like we could write out all the pseudocode and whatnot, and this only going to get 6 marks. But there is a part of it inside the pseudocode where you have to put use of files, and you have to list out the file structure. There is a problem here with the mark scheme. Remember I told you in video 1 that there are 2 problems with this. Narrative and problem description don't have any marks, and this is the problem here. See this here where they have use of files 4 marks? They have appropriate justification of file structure 2. And then description of file inputs and outputs, they have 2 here, but this 2 here is in brackets. So it is believed that this 2 here for description of file inputs and outputs actually falls into use of files, because you can see here from use of files that they only have 2 marks available for selection and justification of file structure. And this one here, they have 2 marks for description of file inputs and outputs. Now it's my hope that they do a syllabus update to fix this problem. But I think what they might either do is they might drop this part here, use of files, to 2 marks, or they might mark you out a 62. I'm not 100% sure, but I believe that they might just drop this to 2, because they realize that this in brackets here is actually what they use of files for. So you'll have 2 here, and this one is in bold. So usually when it's in bold, the or either they have selection and justification of file structure as 2 marks and then appropriate justification of file structure, but this is actually a breakdown of this. So you can make whatever sense you want of that. You could ask the teacher, make sure you show your teacher this, to let them know that, okay, the syllabus has a mistake. So when you mark in, you might have a mark out of, that's my battery there. Yeah. So when your teacher is marking, you might have to mark it out of 62, which is what I think we had to do last year for the first round of the syllabus. I don't know if they will release an update. CX is notorious for releasing updates to the syllabus and the whole Caribbean not knowing. So if it does happen, you could pay attention to the channel and I'll show you all of those things. But yeah. So yeah, this font is 2 here. So I am going to assume that we're using 4 marks for the use of files and mark it out as 62 until I know any different, right? Because the marks won't add up if you do that there. So we're going to, in our documentation, we're going to put a clear spot here called comments, selection and justification of file structure, explain the file inputs and outputs, everything, explain the data structures used. All of that is going to be explained, but we have to put it into the pseudocode. Now, as I said, you could assume that the examiner is going to read through your pseudocode and look for these nitty-gritty marks. These nitty-gritty marks here, use of files, description of inputs and outputs, use of appropriate data structures, demonstration of structured programming concepts, and see if they will be willing to look through your code, your pseudocode, to find that. But I don't trust it. We're going to have specific headings just to do those things, but we have to put it in the code first. So let's start by creating a text file. So we'll go in Notepad and we'll create a text file. So we're going to start off with the basic things that our patient should have. Let's say we have just have this text file somewhere already. Yeah, so I knew I had the file somewhere. Alright, so this is the example of the file input. Essentially, what I have here is an ID number, surname, first name, age, and status. Now, the status could be 1, 2, or 3 depending on if they are good, normal, or intensive care or something like that. No. Stable, warded, and then intensive care. Yeah, so stable, warded, and intensive care. So 1 is stable, 2 is warded, 3 is intensive care. But we'll explain all that when we do the file description. But this is what my file is going to look like. Each patient is going to be like this. What is their ID number? What is their surname? What is their first name? What is their age? And what is their status? That is going to make life a whole lot easier for me when it comes to filtering out the data. So in order to do that, I have to create the structure. And in order to create a structure, there's a little format that I have for our structure here. Structure name, elements, and then create the area structures one time. So I'm going to do the structure declaration. Structure. Name, patients. Elements. When we do this in C, of course, it's going to have the variable types and whatnot, right? So we have ID, first name, no, surname. Why you think this? Why you think I want to put snake? Surname, first name, age, and status. Right. And then create array of structures. P, 1000. Well, I go 10,000, right? This 10,000 here, we're going to change this when we do unit 2. We're going to change the size to max size. And actually, we'll put size here. Right. Now the reason I'm putting P max size is because in global variables, I'm going to create a variable called max size, which will be 10,000. That means that we will be able to hold 10,000 possible patients. And if I wanted to update the program to be able to handle more patients, then I'll just put 100,000 if I want to. But I'll just put 10,000 to start. That's why we create the area of structures P, max size. So this here should let the examiner know for sure, you know what a structure is. You know what the name of the structure is. You know the things that you want to have inside of it, and you want to know the size of the structure. And this structure is going to match the data that I have in your file. And what we're going to do further down, after we finish the whole pseudocode, we're going to give a full explanation of this and why it works, right? Sorry to interrupt the video, but this is future me talking to you while you're watching this. And if you are struggling with a certain part of your IA, or you just need some way to check over your IA, we do personal one-on-one IA classes. So if you want your IA to get a check over, just to make sure you have all the requirements on the marks, makeITsimpleTT.com/register. Okay, cool. Back to the video. Right. So what you would see is you are essentially showing the examiner that you're able to create a structure, you're able to go through the different pieces of data that are in the file and why you structure the file the way it is, all that stuff. What you want to do is you want to structure your file in a way where you have different data types in advance. So you want to be able to have like an integer, a string. You don't necessarily need to have a float unless you're dealing with money. If you're dealing with money, you'll put in floats. But once you have like different data types, you should be okay in terms of the way that you structure it and the way that you explain it. Because it's a database-driven sort of program, all you really want to do is just have the data, and the data could just be ints and strings. If it's an e-commerce based solution, then you'll probably have some floats inside there, whatnot. But let's make sure you structure your data in a way that makes sense, right? So we have that, and right, so I declare the structure, and I declare an array of structures called P, which will be max size. So that means I have 10,000 possible values in a structure called P. Once I have that, the global variables will be like max size and probably other things that are necessary, but nothing special. So let's go to the password function now. The password function will be according to the structure of our function, put the name and then the inputs, right? So we'll put function name, password, check. I'll just name it password. Inputs will be nothing. We don't need to do any inputs. But you will have an output. You will have an output of 1 or 0, right? Now I'm putting this in to show you that this is there's no way for you to show that a return function exists unless you put input and output, right? Because a return is basically an output from the function. So if I put inputs none, output will be 1 and 0. That will let you know that when you're going to actually code your functions, that you have to use a return function. So you have to use an int function to return 1 or 0, right? So then we will start and stop. Because remember, this is pseudocode, so make it look as pseudocodey as possible. You could put a space in between this part here, so you could put the start and stop, so it's kind of clear. Start and stop. So we want to print out that's on. Every time I had to check to see if this thing recording, because I would hate to be doing this and then it's not recording. So print, please enter the password for the system, however you want to say it. Read password. Read password in brackets. And then we want to return password. Yeah. Variables. The variables we're gonna have as password. Right. No, we can't name the function the same thing, so return P. Alright, so read P and then return P. Right. So logically speaking, I asked them to please enter the password for the system. They enter the password. Oh no. And I return in P. I will now say P is equal to 0. And then I will pass code. Now you could read a text, you could read text, but if you read text, you have to end up using string compare. If you want to use string compare, go ahead. String compare will give your program a little more robustness, but you could just read a passcode if you want and read an integer, right? So p password, and then you put the you could hard code the password in code equal 1111, right? Good. So you read p, and then we say if p is equal to code, then return 1, else return 0. Right. Right, so that basically means that when we call this password function, the password function will get called. It will read the p from the user, the code, and if the code is equal to the code that you set in your global variable there, you could do. Now what you could do is you could set the code in the global variables here. That'll make it easier to update the code. Instead of having to look for the code inside a particular function, you could just have the code set out here. But those are little changes that are not necessary in Unit 1, because right now your goal is to just get your functions out and working. When we show Unit 2, we'll be able to engineer it better and do things a little smarter, and make the code much more maintainable and user-friendly and updatable and whatnot, right? So for now, this works. We have code inside there, and we get that. So the password function will return 0 or 1. So if we go down to the main now, you will see that the main will work properly. When we call the password function, it will get a p, and then so while p is equal to 0, meaning p was always set to 0, p never changed, because we read the password and they put in the wrong password, as 0 will come back into p. Is p is equal to 0, wrong password entered, and we'll call back the password, and that loop will keep going because it will just keep calling this function over and over and over and over and over. And bam, that is one function done. That there will get your marks for functions or functionality. But of course, your functions need to be a lot more in depth in order for it to work, right? So let's go to the next one, read file data function, right? So we want to name this function name is read data. The inputs are none, because there are no inputs. Everything we could declare inside the function. And the area structures has been declared globally, so we don't have to send the area structures, because the area structures getting updated on the fly. Outputs, none. Right? So if the inputs are none and the outputs are none, that means it's a void function. You should know that when you're actually doing the C code, when you convert it to the C code. Input, outputs, none. And the variables, we need like a counter. C is equal to 0. I'll put the counter, something like that. Okay, I put a semicolon. You see that there? Don't put a semicolon. Don't. You will hurt yourself. Alright, so let's do the start and stop. We'll fill out the variables as we go along, because I'll most likely need more variables. So I want to read from a file. So I'm going to say open patient file.txt in read mode. Right. It's pseudocode, so we don't have to put all the asterisks and whatnot. And anytime you put them asterisks and you put the file and the equal and R and all those things, lost marks one time, because it's not supposed to look like C. If it looks like C code, you'll lose the marks. So we open patient file in read mode. After we open our patient file in read mode, you will now say while not end of file. read ID, read value, and then put value is equal to p location c dot id. Yeah, right. And then we have to repeat this process. The reason I'm reading value first, then put in p location c id is equal to value. Right, the reason I'm doing that is because I want to make sure that the value goes into the particular location that I want. And that is going to make life a little easier. I copy and paste in here, but just remember, if you copy and paste a lot, you'll hurt yourself. Anyway, so that's ID. After do ID, S name, F name, age, and status. Right. So we read the value from the file, we put the value in. Read the value from the file, put the value in. Read from file, put it in. Of course, when you do it in C, it's going to be a lot different. But remember, different programming languages have different ways of reading from a file. So this here ensures that no matter what programming language you use, you'll be able to put it in correctly, right? So we read from the file, and then before we end off this file, we do C++ and end while. And what we want to do is print a message to say print data has been read successfully. Now you could do a if inside here to check to see if the file is empty and do a null. That's one error check that you could do. I don't know if it's absolutely necessary for you to check to see if the patient file data is correct. That's up to you. But printing data has been read successfully is cool. And then you want to update a variable called actual size is equal to C. Why I'm creating a variable called actual size is because we have max size as 10,000. That means you have 10,000 possible structures. But actual size will start off at 0. And when you read all the information from the file, the actual size will update so that when you're doing your search wouldn't go as far as 10,000. Because if you do a search 10,000 times, you'll get a whole set of weird data coming up. So you must get actual size, because the actual size will tell you how much data is in the file that actually went into the array of structures. So if you have 10,000 possible records but you only have 12 people, you don't want your searches to have to go through 10,000 people when it's only 12 locations you want to search through. Yeah, so I think that makes sense. Alright, so this here is going to read the information from the file while on at the end of the file. Carry up C by 1 each time. Every time I read the value from C, I will do the end while, and this loop will go on until I reach the end of the file. Once I reach the end of the file, I print out data has been read successfully, and then update the actual size of C. All of this is going to happen, and main is not going to care about it because it's not intending to return anything. So when we do read data, that's what's going to happen. So we dealt with the password, we dealt with the read data, and yeah. Okay, so I gave you an example of the clearing structure, I gave you an example of the password function, I gave you an example of the read data function, which will basically open the file and read all the data in. Welcome screen. Well, welcome screen kind of simple. It'll be like function name. Did I put function name? No, let's put function. Function. Welcome. Inputs. None. Outputs. None. Start. Print. welcome to the hospital program. Right, you could make this thing look all kind of way if you want and all that kind of drama, but all I just want to do is put that on the screen. We could put it in the center of the screen, we could tab it, we could go extra lines, all sorts of stuff. You decide how you want to do that. That's quite okay, but yeah. Okay, so all the other stuff here is like add patient, update patient, search patient, remove patient, print info to the screen, print critical patients, print out the menu. All of these functions here, you're supposed to be able to write a function for yourself, right? If you don't know how to write a function, just go and look at, I don't know, probably have some other video about how to do functions or whatnot. But most definitely you'll see me do some of these functions in the code, and I will just kind of reverse engineer the code function and put it inside the in here. Most likely I'll do the search and the update. I don't think I have time to do all the remove because then the videos will be really long. And once you know how to do a function, you know how to do a function. What I will do is I will code the menu function, because the menu function is just going to display a set of values and return something, because up to now we haven't done a return function. Or we did a return function, sorry, with the password. Yeah. So now I'm going to do the menu function to show you how the menu is going to return an option back, right? Because this is the flow of data here. So right now we dealt with the welcome, we dealt with the password, we dealt with checking for the password, we dealt with reading the data, and now we're going to deal with the menu returning the option. And well, then eventually you should go through each one of these options and code each function piece by piece, right? But focusing on the menu now. So let's do the menu and then we'll end up this video. So the menu function name is menu. Inputs would be none. Nothing comes in. The output would be a choice, right? Variables, we'll need to have a choice and set it equal to 0 for sure. So start now, start, stop. What we're going to do is we're going to go with print. Here are the menu options, and then we list out the menu options. But because I'm lazy, I just cannot get the menu options from up here. Minus the bullet points. So we got here the menu options, and then I'm going to put them in. Remove the patient, remove the bullet points, remove the bullet points right there. Print, press 1 for, no, I'll just put 1, add patient. Yeah, and now we're just going to repeat this process here. Tab all in. Yeah. So press 0 to exit. So I'll put the 0 there. This is 1. This will be 2. This will be 3. This will be 4. Wow, this is really boring. This will be 5. This will be 6. Cool. So once I print all of them, I will have to read choice and then return choice. Good. So this will print out, it will print these are the options, and they will read your choice, and then they'll return your choice. When they return your choice, guess where it returns to? It returns to opt, which is the option. And that number that is returned is what we will use to keep this while loop pumping as long as need be. Right. Okay, so there are some other functions that I want to do before I jump out. I'm not going to do all these in-between functions here. All these in-between functions here we will see when we do the code, right? Because I know exactly what to do, but for time purposes, I'm not going to type out all of them because I know what to do the code. And remember, I told you all I'm going to show you all a little bit about how to reverse engineer. So this is where I'll use the opportunity to show you how to reverse engineer, because once you understand your layout here, it's very possible that somebody in your group each person in your group could do one function at a time and then just slot it in. But you just have to have the correct real names. What I will do is I'll call the update file function. Update file is an important function because you have to be able to write to a file. In your IA, you must input to a file and output to a file, right? So let's show how we output to this file here. So do I have a function called output to file? Nope. Password function, read data function, welcome screen, add patient, print critical patients menu. Okay. So I'm going to create a function called update patients file. So function name, function update patients, inputs none, outputs none, no inputs, no outputs, so it's a void function. Outputs none. Start, we will open, what's the name of the file boy? I name it patients file. Open patients file.txt in write mode. Open patients file.txt in write mode. And then I want to print everything as any structure into that file. So I'll say what will I say? I'll say while, how did I read to the file? While not in the file. Yeah, so while not. Oh, I know what I do. We have a variable to tell you how big the file is. So while, I have to create a variable called C counter. Variables C. While C is less than actual size, print p location c dot id, and then print all the other stuff. Yeah. C.name, location c.f name, location c.value, age, location c.status. And then I'll carry up C by 1, C++. And then end while. Did I do an end while here? Oh, I did, yeah. End while. Alright, so this while will print to the file. Print. print. Cool. So this function here is going to be my update file function. So what did I name it? Update patience. So I'll put update patience. Right. There are nothing being sent it. And then the exit program message will just be a exit program. Right, so that is going to make your life a whole lot easier because now I have a functioning logical program. The only thing I haven't done is add in all the functions, but once you can get this skeleton in place, then you have enough to be able to start coding. If you could get the skeleton out of the way, then yeah, I think you could jump to the code from here and then just fill in these functions as you go along, and as you get them to work, you reverse engineer the functions into each one of these spaces. You should be okay there. So yeah, I'm probably on an hour for this video already. I didn't want this video to be so long here, but there's the meter, there's your big marks here. So there's a whole 21 marks we're looking for here. So I want to make sure that you understand there's 21 marks. This is not no baby marks here. Right? So I think it's actually 23 marks here looking for it. So the flowcharts and stuff, the thing being easy to follow, we basically making sure that it's clear and it's laid out properly. Now we want to get to the part where they have use of files, description of file inputs and outputs, use of appropriate data structures, demonstration of structured programming concepts. So here's how we get those marks. So after you do out all your pseudocode, now this is assuming that every single thing is done, including your functions, right? But we have a lot of functions inside here. I have a lot of examples of functions that are working, but of course all these other functions here still have to be put in. But I'll use the examples that I have here to show you that we have gotten the marks so far. So comments must be included. They clearly said that inside there, somewhere inside here. Oh no, I put in the comments. The reason I put in the comments is because you want the examiner to be clear about your intention. Most of the comments will be placed in your code also, but you need to be able to differentiate the comments, or you could put them in italics. Now I put them with 2 forward slashes because every time we have a particular thing that we're doing, I want to put, okay, this is the main, this is the menu, this is the update patience file, all of these things. All those comments there are just to remind the examiner that you know what you're doing. And you put a comment there to show. And when you do your code, you're going to make these comments a little more robust. But you see the clear layout of what is expected for each function, that matters. So put in the comments, and I don't want you to put a heading for this, but you could also prove that you put in the comments by showing that, right? So I just put this in for within your pseudocode. You need to ensure you gain all the marks by showing that you know why you put things in. But remember, as a human being, you try to convince that you know what you're doing, or your group know what you're doing, right? Selection and justification of file structure, right? So this one here is important. So the selection and justification of file structure is going to tell the examiner that in that pseudocode, you know why you did what you did. You didn't just copy it from somebody because that's where you had it. You were able to explain it. So an example I have is the file input.txt is open in read mode so that the initial data can be read in the system and stored in an array of structures. The file used in a text file because it is easy to read from all system elements, so it will be displayed in the following format. Right. So I'm just going to copy this exact same paragraph here and change the words because that's basically file there. That's exactly what I want to say. Except for I'm going to change some of the words. So I'm going to say the file patience file. That's what I name it, but did I name it? Patience file. Yeah, patience file.txt, right? The file patience file.txt is opened in read mode so that initially it can be read and stored in the array of structures. And I'll put the array of structures P 10,000, no P max size.
Yeah, that's points again there. The file as uses a text file because it's easy to read on all systems. The elements of the text file are stored in a space-delimited format to ensure elements are read properly. And I'm going to say that it is ID. The format used was ID, first name, surname, first name, age, and what's called status. Alright, and if you want to sprinkle a little salt on it, you want to channel in a salt bay, then take a print screen of this here and hit emit one time. You like, yo, I know what I'm doing. You could make it smaller and show that, right? You make sense about what you're doing there, right? So if you train our print screen, you will see that the format is there. And guess what? That is your 2 marks, huh? See use of files. Well, 4 marks actually. So in order to get our 4 marks, I needed to write this paragraph here to get 2 marks, write out the format, and then hit in my print screen. I guess that'll be the 4 marks. Description of file inputs and outputs. Then you want to describe your input files and your output files, right? So this example here is, this is some good stuff. And this stuff is so good that I'm going to jack it. Oh wait, no, I had to put the file structure for the no, that's the file structure. Oh no, I need to put the file structure for the output file. Okay, that's important also. The output file used output critical patients .txt will just list name of the patients. It is a simple list needed for the doctors. The format used was surname and first name. Right. So you'll have some output file. I'll probably print out critical patients.txt. And well, when you actually run the code and you get the output file, you could lay it out like that. But you could put the output text file there as a little icing on the cake there to show that the way you structure it and why it's structured, because it's a simple list that is needed. Alright, so then you want to do the description of the files, stating what is happening. So you have your input files, patients file.txt. This file contains all the patient data using numbers to represent the patient status, since it would be easier to search. Output files. The output file is critical patients .txt. This file displays a filtered set of names of patients who are in critical condition to be printed. Right. So that now gives you next 2 marks, because you show that you know that your IA collects an input file, you know what the input file is for, and you know your IA does output file, because you must have an input file and an output file in your IA. You can't do your IA without an input file and an output file. So what we did is description of file inputs and outputs. So it's the sources, the types of inputs, and states what the use of the output is for. So you realize in mine, I said it uses numbers to represent patient status since it's easier to search. So you're trying to show that you know what data you're putting in the file and why that file is structured that way to make sense for your particular use case. So we use numbers because it's easier to search, essentially. And then your data structure used, you want to now explain to the examiner that your data structure matches your file. So your key words here would be something like the structure contains 4 pieces of data that mimic the file structure exactly. Ints are integers are used for the ID, age, and status because they are whole numbers. Alright, you want to flex that. Then you also want to flex that strings are used for the first name and surname because they are words. Yeah. Right, so data structures used is 2 marks. No, that's all 6 marks. Yeah, so for the 6 marks, you're trying to show that the data structure that you use was appropriate, right? So, so you gotta give a lot more to get that 6 marks. So you want to be like, what did we name it? We named it structure name patients P max size. Okay, so you want to know patients P max size, patients P max size. Right, so we want to dissect this as much as possible. So patients is the name of the structure. P is the name of the array of structures. Max size is the global variable used to define how many patients are accommodated in the system. Alright, once you give them that, you know, showing, okay, I know what a structure is, I know what an array of structures is, I know why it's used. You'd say an array of structures was used because it can hold different data types in one record, thus making it easier to group the patient's info for greater searchability. It's almost like you're answering a question. It's very much almost like you're answering a question. So searchability, yeah, that's what we're looking at. And then you want to say what the structure has in it or whatnot. That is going to find you your 6 marks. If you do get 6 marks there, I don't know. So the data structure chosen were appropriate for the problem definition. So you are saying you know what your problem is, you know what the file is, you know what each part of the data structure is, you know why you choose it, you know what you put inside of it, what types of data there are, integers and strings and whole numbers. You're answering a question for 6 marks basically. And then structured programming concepts, you want to make sure that your program is listed out. So for structured programming concepts, you basically want to say the structures, each component of the program is laid out. Now, for the structured programming concepts, they're going to have to look at your pseudocode to give you the marks fit. So what you write here is basically just telling them why I laid out your pseudocode, right? So each component of the program is laid out in such a way that it can be followed. The main uses indefinite while loop and indefinite while loop that would only stop user interaction and makes it easier to follow user interaction. Each independent function makes it easy for the user for the developer to update and debug the code. Right. So picture yourself answering a question for how much marks? 5 marks? Yeah. So when they say design demonstrates excellent use of structured programming concepts, you want to tell them, I have my structured programming concepts down. I have my while loops, I have my for loops, I have my other loops, I have all of these loops. And you just want to give a paragraph to show that I put effort into using the loops. You could put variables, global variables we used so that they could be updated easily. The structure was declared globally to ensure all functions have access to it. Yeah, welcome and exit screens were put in. All code was indented using standard tabs. Yeah. Right. If you could give 6 things here to show that you have done excellent code management, cool. So list out your 6 things and just make sure that your pseudocode matches up to that. When they go back to the pseudocode, they must say, all right, yes, they did use standard indentation, they did use this, they did do that, they did put the functions a particular way, they did lay it out globally, they did show all of that. Yeah, that's what you want to do. And that's going to give you your 21 marks, right?
Alright, so now that I reached the end of this video, I want you to understand that pseudocode accounts for the most amount of marks in the IE. It actually accounts for like a third of the marks, right? You might think the code actually accounts for most of it, but it's really pseudocode. So what you want to do is you need to make sure that you understand all of the different things that they want you to list out. So all of those things I listed out there, and I showed you the things that are given marks, and think of it like you're answering questions in a past paper, because essentially that's what you're doing, answering questions in a past paper. So when you answer those questions, you want to use your pseudocode to show your skill and understanding of programming. Because actually writing the code, anybody could take code from somebody else and run it, but to be able to explain what is going on inside the code, that is where you're making most of your money. So pay attention to that, right? And what you could do, of course, is remember to check out the Learn It app. If you're watching this on YouTube and you made it to the end, probably you don't have a teacher and your teacher not able to help you, or you don't understand properly, and now watching this video makes you understand exactly how to get the best marks out of the IA. Cool, good. If you download the Learn It app, you will see so many other resources there, past paper questions, answers, you might even see this PDF, all sorts of things will be inside the app. So go to makeITsimpleTT.com/learnit. Link will be in the description, of course. But you can check that out and be very careful when you're doing the pseudocode to make sure it doesn't look like C. Next video, we'll definitely be doing the C programming, so we will get to the code next and see how we could turn this pseudocode into actual running program, right? So see you all in the next video.